So what I've got here is this will be the third video in a set of three on second order homogeneous differential equations. And this time we're going to be going over the complex solution case. So let's do it, and we'll start with this problem on the board on the left. So we have y double prime plus 4y prime plus 5y equals 0. And what we want to do right off the bat is turn this into the characteristic polynomial equation. So we basically just turn it into quadratic. That's not a y, that's supposed to be a r right there. So we just have a quadratic equation. And normally, so we'd be looking for factors, but I pretty much, we know there's not going to be any real solutions to this. What I'll do, let's go right to the quadratic formula. And so we'll have minus 4, minus b is 4, so minus 4 plus or minus b squared minus 4, a is 1, c is 5, over 2a, which is just going to be 2. Okay, good. And then let's reduce that a little bit. So we're going to have minus 2 plus or minus, let's see, this is going to be 16 minus 20. So this whole thing is the square root of minus 4. You probably can't see that. Minus 4. But that's just going to be 2i. And then let's just simplify a little more. So we get minus 2 plus or minus I. So those are going to be our two roots. And now it's the interesting part. So let's write this as two separate roots. So we'll have our first root alpha is going to be minus 2 plus I. And then our second root beta minus 2 minus I. And knowing from the previous videos how we want to express this answer, let's just write it out that way. So if we have our two roots, we have our first root, our second root. Now technically, this isn't wrong right here. So this is true, but we generally don't express the answer this way. I don't know if, like, if you're taking the class, if that would maybe be partial credit. I don't know. But what we can do, let's look at how we can express this better. So so just using, well, so first of all, if you distribute the t in both these cases, we can rewrite this. So let's rewrite this like this. And then just using just using exponent rules, this is the addition of the exponent is just multiplication. So we can write this again. We can separate this out like this. And then we can see we can factor out, we have this term in common. Okay, so we can then factor it. So let's do this. And what we can do next is we can use Euler's formula on these terms. So let's just write aside, let's just write those out. So what this is going to be, just using Euler's formula, that'll be that. And then this other term will be cosine of negative t, but cosine of negative t is the same as just cosine of t. And then it would be I sine of negative t like this, but a negative angle on the sine is actually the same thing as bringing the negative up front. So we can just rewrite it like this. Okay, good. So then what we can do, let's just plug these values back in, and let's see what we get. Yeah, let's just go full screen. I should have done that sooner. That's okay. Okay, plus, we got our second constant, and then we'll just bring this guy down. Okay, then what I'll do, so we can distribute our constants, okay, and then group like terms and change colors just for fun. Let's kind of combine some steps here. So we'll have C1 plus C2 times cos of t. And then on the other one, we're going to have, let's see, I think it's going to be C1i minus C, let's do, let me get it together. So we'll have C1i sine t. I'll do it that way. We'll have C1i minus C2i sine t. That. Not a good t, but okay. Can't do better. Okay, we have that. And so the thing to notice here is this C1 and C2, we don't need that because the arbitrary constant, it represents, that's all numbers. That's just any number. And so C1 and C2 is just another constant. So let's rename this as C3. And the same thing with this. This is just, now even though it doesn't matter that there's an I in there, it's in terms of looking at this problem, it's just all a constant. If you differentiate, if you try to take the derivative of this, it's just zero because it's just a constant value. So we can call this C4. But then, so finally, if we're going to write our final answer, I can use C3 and C4, but the thing is, it really doesn't matter what we call it because it's just an arbitrary constant. So I'm just going to go back to calling it C1. So if you could call it whatever, I mean, you could call it A and B or whatever, but I just want to stick with the convention of calling it C1 and C2. So we'll do that. Like this. And then we'll have our C2. And that'll be our answer. And the thing to notice, so when you do this normally, you're not going to go through all this stuff because you don't have to prove out Euler's formula and the simplification every time. What you can do is we had our solution in this form. Let's just call this a plus or minus bi. So then your final solution is going to look like that's the a part in our a plus bi, right? If our root's a plus or minus bi, we'll have b on the angle, and then c, this piece will be the same. So this will be like your general form. So once you have your roots, unlike the real case, you don't have to, the roots are always a conjugate, so they're always in this form. So you don't have to get two separate roots. You're just worried about the real part and the imaginary part. And the real part will be there and the imaginary part there. And keep in mind occasionally, right, so occasionally in this case, you won't have a real part. You could have your root as just plus or minus bi. And then in that case, this term here will go away, this term here will go away. And your solution would look like something like this. It just becomes the trig terms, the cos and the sine, like that, and the exponential term drops off. And so you'd have like this little subcase here. So let me just check this answer. Let's bring it back. So we had e to the minus 2t cos t. Oh, didn't mean to do that. Okay, nice. So check this. So looks like this case right here. That's correct. So that covers the complex case. And again, I'll provide a link to this quiz. So if you want to do some practice problems, we have the real roots and the repeat roots and the complex roots. And in this help, there's a little bit more instruction, just covering kind of what we went over in these three quizzes, and a link to the differential equations cheat sheet. So I think, and then next book we're going to keep going. I'm going to do more differential equations. We'll just be moving on to a different topic.